P4 number 46. We want to simplify this rational expression. Okay, so what we want to do is we want to see if we can break up our polynomials into things that are multiplied together on the top and multiplied together on the bottom. Because if we then find the same thing multiplying both on the top and bottom, we can use a rule that anything over that same thing is equal to 1 and simplify our expression. All right, that should be a plus. Okay, now on the top, we see that there is a y in every single term. That means we can reverse the distribution. I always call it pulling out, right? We pull out the y. Y times y squared gives us y cubed. Y times minus 2y gives us our 2y squared. And then minus 3 is the term that is left over for the third piece. Okay. Now y cubed plus 1, that's one of those special ones, right? That's one of those special factors that we wanted to remember. And so on the bottom, we're going to have y plus 1 times this quadratic. Quadratic means that we have a square in there. Okay, this is going to be y squared minus y plus 1. Right. I will leave it to the interested student to determine that this bottom is in fact the same as this bottom. Okay. Now, can this be simplified any further? Okay. On the top, right, we have y squared minus 2y minus 3. Okay. Now, this minus 3 indicates that if we can break this up into two binomials, one of them's got to be negative and one of them's got to be positive, right? So minus 3 we can break up as 1 times minus 3 or minus 1 times 3. And the question is the sum of either one of these equal to negative 2? Well, 1 plus a negative 3 is 1 minus 3, which is negative 2, right? So these guys allow us to break up this quadratic on the top into two more factors, right? So we're going to have y, which we pulled out of all the terms to begin with. We're going to have a y plus 1 on the top, and we're going to have a y minus 3 also on the top. Okay. So now this top is the same thing as we had before, only in as a product of either y or these binomials. On the bottom, we're not able to break up this into extra pieces, right? We would like to, right? This plus 1 indicates that this could be a positive and a negative. I'm sorry, either two positives or two negatives. But unfortunately, 1 times 1 is the only way to get it, and we can't either add or have a negative and a negative and get negative 1, right? We would either get positive 2 or negative 2. So this can't be broken up into any extra terms, any extra rational numbers, right? But so we're left with a y plus 1 on the bottom times y squared minus y plus 1. Okay. All right, now, are there any terms that can cancel out? Do we have the same thing on the top and the bottom? Same thing multiplying the top and the bottom. We need the multiplication because to do this properly, we need to break this up, right? We have a y plus 1 over y plus 1, right? If I pull one of these guys out on each of the top and the bottom, I can do their own fraction as a multiplication, leaving us with a y times y minus 3 over our y squared minus y plus 1. And this, as long as y is not equal to negative 1, right, which would give us a 0 over 0, and the zeros don't like being on the bottom. This cancels out to 1, leaving us with this fraction of y times y minus 3 over y squared minus y plus 1, as long as y is not equal to negative 1. Okay, because we still have that 0 problem that we had when we constructed it. The hole was in it when we constructed it, so it remains there after the construction. Okay, so this is our simplified solution.